Number 5 has 3 different parts to it here. So the first part says complete a table to determine the residuals for the cost. So we did one of these in class in our book. We've got our X data here. So this is going to go into our L1 in our calculator. This is going to go into our L2. And then we're going to figure out what to do with our L3 and L4 so that the calculator can do the work here. But if we read through this, it says the average cost of renting a compact car for a day increases over a 6-year period. The linear regression equation for the data, they already gave us the linear regression equation. That doesn't mean that you can't calculate it. We could calculate it, put the L1 and L2 in, and do a linear regression, and we would come up with this equation. But this is the equation that we're going to use in order to find the predicted price. Okay, so don't round it differently and do different things with it. When it gives you it, we're just going to use that. So it says complete the table to determine the residuals. So first thing I want to do is go to my calculator. I'm going to put this data in my L1 and L2. So we hit stat enter. And I have stuff in here from class. So what I'm going to do is I'm going to clear all of that out. You go up to L4, so it's highlighted. And then you hit clear enter. And it clears out everything that's in there. Do the same thing with the other one. So make sure you're up at the L3, clear, enter. Okay, so now that I have them cleared out, I'm going to put 0, 1, 2, 3, 4, and 5 in my L1. And then we go over to the L2, and we're putting our L2 data in, the 46 and 54 and so on. And then we want to figure out what the predicted price here. Now the predicted price is what this line would predict for it to be. So if we want to know what this line would predict it to be in year 0, we would plug 0 into that equation and we'd get 41.33. And then if we wanted to figure out what it would be at year 1, this is our X, so we'd plug 1 in and we would find what our Y value is. That would be the predicted price. So you can do each of them on your own if you want, or if you know how to use your calculator, you go up to the L3. If the L3 is not highlighted, this will not work. Okay, so make sure you're up and the L3 is what's highlighted. And then we want to put this equation in there so that the calculator does all the work and we don't have to do this 6 different times. Okay, so we're putting 12.8, and instead of times X, because your calculator doesn't know where you put the X values necessarily, our X values are here in my L1. So instead of times X, I'm going to put times L1, and you can see L1 here above the 1 in blue. So I have to hit this second and then hit that button and it'll put L1 there. So second L1. Then we still have to do plus 41.33. And we hit enter and it should fill all of that in for you. So all of those numbers will get written here. And then the residuals. So let me just drag this. Let's get them written down before we get too far ahead of ourselves. Okay, so the first one there was 41.33. And our 54.13 and so on. So go ahead and get those written down. Okay, so I've got that written down. Now I'm going to delete this. It's still in my calculator. So now I want to figure out how to get my residuals over here in my L4, or you can do them by hand if you want. So the residuals, one thing that you really should know about residuals residuals are equal to the y values minus the predicted y values. So if you think here of where our y values are, these are my x's, and these ones here are my y's. So I want to take my y's, which are my L2, and then I want to subtract the predicted y, which is this predicted right here. So this is my L3 in my calculator. So you can just do L2 minus L3 and it'll fill all of those in for you. Or you can take this value here, my y, and then subtract this value here, and it would fill in the residual, and you would do that for every single one of these. Okay, it's easy to make an error there, but it's not difficult to do, and there's not too many values to do it that way. So if you prefer that, you can. I am going to go up to my L4, so make sure the L4 is highlighted, and then we want to do L2 minus L3, and it's going to do all of that for us. So L2 is above the 2, so we have to do second L2 minus second L3, enter, and it gives us all of our values there. So I'm going to go ahead and write those down. And you'd get the same thing if you did it out by hand. Okay, so we've got the table filled out. And that's all it says to do here is complete the table to determine the residuals. So now construct a residual plot. So if you notice here, it says residuals here, and it says year down here. So when we look up here, our year is what's in L1 and our residual is what's in our L4 over here. So you are plotting the data from L1 and L4. Okay, that's where those always will be located if you're doing it this way. All right, so we can use our calculator or we can use the table above. It's the exact same thing. For the first one, at year 0, so I'm looking at this data value here and pairing it with this residual here. 0, we're going to plot it at 4.67. So 0 up to 4.67, which is almost 5. And I think when you submit this on Edge Elastic, if you're doing it that way, I think it tells you to round it to the nearest value, so you would plot 5 there instead of 4.67, okay? So you might have to round them to the nearest whole number if it says that on there. Okay, then we move to the next one, and it's at 1, so 1 is my x here, and then it's down 0.13, so it's at negative 0.13, so just below the axis. So I've got this one done, I've got this one done, then we got 2 with negative 6.93, so almost negative 7. Then 3 with negative 4.73. And you can plot the last couple. All right, so we've got our residual plot done. And now we want to look at part C here. And part C might be the hardest part to know that you got the right answer, because some people have different opinions on whether they see a pattern there or whether they don't see a pattern there. So when I look at this, it goes like this, and then this, and then this, and they're kind of all over the place. I feel like there's not much of a pattern there. So I'm going to go ahead and I'm going to say there's no pattern. So if there is no pattern, and that's me explaining why I'm choosing what I'm choosing. If there's no pattern, do you think a linear model is a good fit? The answer is yes, a linear model would be a good fit because there's no pattern in the residual plot. So no pattern in residual plot. I might want to specify that a little bit. And then we can say, so yes, let me, or you could say yes because there's no pattern in the residual plot. So no pattern would be a yes. If there is a pattern, that's when it's a no. So if you remember, I think it was like maybe page 202 in your book, if there is no pattern, so like the points seem to be pretty random, then it's a line is good, okay? If there is a flat pattern, they call it, so like some points up here and some points down here where it looks pretty flat, then it's the same as this one, okay? So no pattern, this would be yes, a linear model would be good. Okay, but the no's are when there is a pattern. So sometimes, I think in the book, it was something like this, where it looked very curved, I would say. Then this one would be a no. So if you saw something like that, it would be a no. So any type of a pattern, it could also be like where, whoops, it's jumping around there on me. It could also be where, I don't remember if it started fanned out and then went together, if it started together and then went fanned out, but if the data starts more fanned out and then gets close together out here, that's a pattern. Okay, the residuals are far away to start with and then they're closer as you move on, or vice versa. It could start closer and then it could fan out, and that would also be a pattern, so that would also be a no. Okay.